Hi everyone, so I'm Jack and this is Francisco. And yes, we're going to share the story of a pretty significant production outage that we had last year, actually just before the Christmas holidays. But first, we work at CERN, and CERN is the European Organization for Nuclear Research, based outside of Geneva, Switzerland, and it's actually right on the border between Switzerland and France. It was established in 1954, and it has since then focused on exploring the smallest particles in the universe. So for that, we have this giant underground accelerator that is called the LHC, the Large Hadron Collider, that is 27 kilometers in circumference, and it accelerates particles almost to the speed of light. At the site of the experiments, these particles are then collided, and the experiments have detectors that are like very, very high speed and high resolution cameras that capture what happens during these collisions. These are very, very big machines, and what these big machines also do is they produce a lot of data that needs to be stored and analyzed, which is happening in our on-premise data center. Most of this data center is used for batch workloads, such as analyzing the data, running machine learning models, etc. But a part of it is also used for the so-called online services. As some of you might know, this guy also used to work at CERN, Sir Tim Berners-Lee. And what he did during his time there in 1989, he invented the World Wide Web so that scientists could share information with each other and link between the information with hyperlinks. So since then, we've been running websites at CERN logically, and today our web services infrastructure is based on Kubernetes, specifically on the OpenShift Kubernetes distribution OKD4. We have 4 different production clusters that together are hosting more than 8,000 websites, web applications, APIs, and other forms of HTTP content. All of this is managed by a pretty small team, and to keep up with the demand that we have for managing this infrastructure, maintaining it, but also with the users that need support, we do need a lot of automation, because otherwise we couldn't handle the workload with such a small team. If you want to learn more about this infrastructure, we also gave a presentation at the beginning of this year at the OpenShift Commons gathering, which I've linked here, so you can watch it later if you're interested. On a very high level, our infrastructure looks something like this. So we have an administrator that is putting the cluster configuration, Kubernetes operators, storage components, etc. in place by using a GitLab CI deployment pipeline. So all of our configuration is completely described by infrastructure as code. On the other side, we have the things that users give us. So they are running their websites, such as home.cern or other websites, and these are completely self-provisioned by the users, so it's a self-service interface. And all of this then comes together in the Kubernetes cluster, where the thing here in the middle is kind of the interface. It's the Kubernetes API, where we, as the administrators, provide services from one side, and the users put in their workloads from the other side. Now, a quick introduction for those of you who are not familiar with Kubernetes operators, because it's a very key component to our infrastructure. Kubernetes has its native API that are things like pods and deployments, but you can also extend the Kubernetes API through so-called custom resource definitions. So you can provide a schema, and then these objects will also be supported by the Kubernetes API, even though they are not native to Kubernetes. A custom resource is then a concrete object that implements the schema described by the definition, and the operator is then the component that reconciles the state that is described in this custom resource. So it will make sure that the state is as described. what happened there? Yes, and this provides a really powerful base for building your own service as a service, or software as a service, which we've talked about in this year's KubeCon actually, so there's a nice presentation about that, how you can build up a self-service SaaS for this type of, with this type of model. Now, let's get a bit more into the specifics. So this is an example of such a custom resource. In this case, it's a Drupal site because this incident affected the Drupal cluster. We can see that it has a name and some configuration parameters, such as, most importantly, the URL of the site that the user wants to have created. Then there are also things like the version, and this gets taken as an input by the operator, which then makes sure that the website is running, it creates a database, it sets up ingress resources, and then it populates the status at the bottom. So we can see that the deployment has the expected number of replicas, the database was checked for migrations, etc. This infrastructure then powers some of the websites, some of the most important websites that we have at CERN, such as the homepage, but also other websites that are used for public outreach. So it's really important for us that these mission-critical websites are always available and running. Now let's get to the incident that, like I said, happened just before the Christmas holidays, and I'll hand it over to Francisco so he can describe to you in detail what happened that day.
All right, so let's get to the juicy part. It was a normal day in December. We had this tiny change here that you can see. And what this tiny change does is basically we're disabling one version on that custom resource definition that we saw previously from users. So we don't users to use this specific version. And as always, we basically trigger this update of this change through our pipeline. So we update the configuration of the cluster to not allow this version to be used by the users. So very simple, we first push to staging. Our infrastructure monitoring says everything is healthy, everything is fine. So we later in the same day push to production because there's no good reason why anything should go wrong. So we push to production, and just a few minutes later, multiple messages start coming in. So some colleagues start asking, is the Drupal down? Is home.cern is offline? Can you check what is going on? As well as our automated monitoring systems for the application layer, which we don't have in the staging, also start firing, saying, hey, look, websites are offline, please have a look. So I went to have a look. I was expecting this, but instead I got this. Uh-oh. So by now, I realized that the pushing to production made this website offline. I went to check into the production directly, and not only this website, but all the websites at the cluster were gone and fully disappeared. So let's look into the timeline events. So we push to production. For a few minutes later, alerts start coming in. We do an initial assessment, so we check, okay, indeed, home.cern is offline, which is already bad, but all the other websites are also gone. And we do what we believe should be done immediately as the first thing, which is we should reset the cluster configuration to the previously known working state, because at this point we don't know what happened, but we can try to correlate that it was clearly linked to the fact of the latest push we did. So the rollback, it's quite easy for us to be done. Here what we have is basically a screenshot of our pipelines on GitLab, and to basically restore the cluster to a previous configuration, we do it the GitOps way. We go to the previous release, the previous commit, we go to the pipeline, we do the check, and now the cluster should be in a state where it should be working. So, okay. So again, looking at the timeline of the events, we now have fully resetted the cluster to a known working state. But we want now to basically disable all automation in order to restore. Because mind you, what we have in our CI, on our infrastructure, we have infrastructure as a code, but we don't have like the application layer. So the applications are not in code. They have to basically be fully restored. So we first disable this automation so it doesn't get in the way of our manual operation. And we also fully assess what happened. So in here we have basically a sort of a diagram with the important components in order to serve these websites. So in our Drupal cluster, we have what we would call internal resources that are important, such as the Kubernetes manifests. So these Kubernetes manifests were gone in a non-working state, and now we know that we have fixed it. But now we still have to restore the custom resources, because the custom resources are necessary, as well as we have to assess what's the state of the external resources. We don't know if they're also deleted, if they are somewhere hanging around, and we can just basically reattach it to the cluster. So we basically would have to still go and understand if the databases are there, if our authorization API, which basically takes care of the lifecycle of the applications, still contains all the authorization credentials, etc., as well as the Ceph volume, so the storage side of the websites. So looking again into the timeline of event, we disabled the automation. We understood now the full scale, and we now want to prioritize the procedure of recovering everything. So we look at the whole instances we have, because like my colleague just mentioned, we have many websites. For Drupal specifically, it's 1,200 at that point in time, and we needed to restore them all, but there are some that are more important than others. So first we restored home.cern with a specific procedure. So basically we have some web presence spec online, and then we're going to go over it and understand what else we need to do. So regarding the full outage, and we basically looked at the components again, and we saw, okay, we still don't have the custom resources. We checked that the authorization API is there, so there's nothing to recover there, but we still need to restore the volumes. We still need to restore the databases. So how did we do that? For the custom resources, we use something called Velero. For the ones familiar with Kubernetes, you might know about this component. This component allowed us to basically restore these custom resources that are necessary to serve the websites. And then we also, through the Ceph volumes, we basically have something which is really nice, and it was really handy. So when we delete any instance, the volumes, we don't immediately delete them. We basically put them in this detached state for 30 days, and only then it gets cleaned up. So for us, it was really easy to restore the volumes. All we had to go is to check these volumes and basically make them attachable again. I'm not going very much into details of these commands, but it was just this. So with this, looking back into the state, the databases, the databases are still unknown, but the volumes and the custom resources should be back. So looking again at the timeline, this is in the next day. So now we already fully assessed everything. We already restored the volumes. We already restored the custom resources, but we still needed to recover the database. To have the database without any data loss, we requested on the next day to our database team to basically do a recovery in time procedure to basically have no data loss. And by the end of the second day, we basically had restored everything. So we restored the volumes, we restored all the custom resources. Everything is back. Okay, so now we are now wondering. So we went through all this procedure. We went into this emergency mode of basically everything is gone. We restored to the previous known configuration. We put everything back online, but we still don't understand what happened. So how did this push deleted everything? So what actually happened was that there was the cluster had been misconfigured. There was a bug in the tool that basically pushes this configuration to the cluster. And this bug had been introduced into the master branch right beforehand. So the actual bug is this one. I know it's really obvious. It's not. It was not for us. When we looked into the master branch, we saw this change in the deployment configuration, and we thought, okay, this should be this was first reviewed, etc. So it should be not a problem for us to merge with this change of the deployment tool. So on our deployment procedure, this same commit that we just saw has to go through multiple steps. So we first have end-to-end integration tests, and this is something that is really like end-to-end. So we create a full cluster, we go and put all the cluster types, and for each cluster type we do multiple validations, and everything was working fine. We also do code reviewing, so before it also reached the master branch, that same commit had been reviewed and checked by more than one person. And it was also pushed, like I mentioned in the beginning, it was pushed first to staging, which again didn't trigger any alert, so everything should be fine at least from expectation. And there's usually also some manual validation on the staging environment that everything from the infrastructure aspect of things is running properly. And all of these checks on our process failed. So the last stage is we deployed to production, which we did, and everything was gone. And this is when our monitoring tools start kicking in. And for the external monitoring, some of you might know them as well as users. They also start kicking in and complaining that the websites went offline. So you also saw that line before, and it was not obvious to you as well. It was not obvious for us why everything got deleted with that change of line. But it's really ingrained, and it's really specific for us. So we have another operator, which we call the auth operator, which takes care of the life cycle. So imagine you're an owner or a physicist, and you have your own website, your personal website, and you create your website, and then you leave CERN. We have an API which also lets us know about these kind of things, and we also will decommission these websites once someone leaves CERN, for example. And this is the component that also takes care of the said life cycle. So it's really a very powerful component. It's capable of deleting projects, which was the case. And there was basically this subtle bug, which basically made this component look at the staging API and not the production API. And the component was, in theory, very resilient to multiple mistakes. So the component would have not deleted if the API was not responding, or if the API responded but it was an empty response. But what the component never expected was that it was able to communicate correctly with an API. The API responds in the correct format with the correct list, but not the list we have in the cluster. So that meant for the component, it's time to delete everything. Yeah, so right here we can see basically from our audit logs what the operator did. And basically in the morning what we actually see is the deletion from the staging, because we were not monitoring staging, so staging was also gone. And then it was pushed to production, and then basically within 20 minutes everything was deleted. So now what's the lessons learned, Jack?
Yes. So that was a really stressful 2 days. Luckily, we managed to restore everything just before the Christmas holidays, so that at least we could go home in peace. But now we want to share with you some lessons that we've learned specifically from this incident. So there are obvious things like infrastructure as code and monitoring, but we were already doing this. So I want to focus on the things that we've improved since then, and what we've changed. So one thing that my colleague already mentioned is the soft deletion aspect that we already had for the CEFFS volumes. So instead of immediately deleting the data on the volumes and throwing them away, we keep them in a detached state for a while. And this is a really good thing to do in general whenever you have the possibility to do it. So delaying the actual deletion. In some other contexts, this is also called a brownout or a scream test. Because if this, whatever you're trying to delete, is actually still needed, it's really easy to recover it in that moment. So this could be something like detaching a volume but still leaving it there and then deleting it later. But it could also be, in the case of a website, just stop serving the content but actually leave all of the other resources in place and then clean it up a while later after a grace period of 1 week or 1 month or 3 months. If possible, also taking a backup of the resource before you're actually deleting it is a really good idea. But all of these things are sometimes kind of hard to implement. Yes, it's easy if I just have a folder and I'm going to take a backup of it before deleting it. But what do you do if you have something configured in a cloud API, like a cloud load balancer? How do you take a backup of that? So this really needs to be reviewed for each individual component, how you can implement such a strategy, but it's always worth it to do it. And since this incident, we've actually implemented this for many more components of our cluster, such as, most importantly, also the projects themselves. The other really important change that we introduced since then was having an accurate preview of which changes we're going to deploy to our environment. So we didn't have this before, but we only had the code reviews, which is kind of reviewing the input, but then you actually also want to review the output of whichever deployment tool you're using. So this can be something like Terraform Plan or Argo CD application diff or whatever you're using. So we've since changed our pipeline so that before deploying, we always look at this preview, and that allows us then to exactly see, in our case in the YAML manifests, which lines are changing, which manifests are being added, which ones are being removed. This allows us to catch when we're maybe deploying something unintentional or something that we were not aware of, and it gives us a lot more confidence in our deployments. The fact that we had fully isolated environments for each of our production clusters also helped us greatly. So despite using Argo CD for managing these clusters, they are not connected. So each one is fully separate. It has its own OpenStack project, its own credentials, its own volumes, etc. And this prevented the outage from spreading from one of these clusters, so the Drupal one on the left, to the other ones, which might have happened if we had like one master cluster that controls them all. During the outage, it was also very, very important that we were able to be flexible with our procedures. So most importantly, of course, the recovery procedures. So we have documentation for recovering resources from backups or wherever else. And usually we need to follow a specific recipe. But my colleague already walked you through the fact that in this case, only some of the external resources were actually deleted, whereas other ones were still in place. So on the fly, we had to adjust these procedures. And for that, it's very important that the administrators or whoever is the operator is familiar with the tools so that in this really heated moment, you are able to quickly make decisions and make the right decisions to change your procedures as necessary. Communication channels are, of course, also a big topic during such a significant and, especially in our case, public outage. And it can be challenging at times with all of the different inputs that are coming from different directions, stakeholders being involved. So in our case, of course, users are contacting us, but also other service managers are contacting us. Hey, what's going on there? Can you restore this or that? But it's also necessary kind of to quickly find the right mitigations and solutions for what you have in place. So one thing that we did is we set up redirections to let people know that, hey, we are working on recovering this, and please be patient. Francisco already mentioned that the first website that we restored was the CERN homepage, home.cern, and together with that, we restored a couple of other what are considered mission-critical websites for CERN. And this is something extremely valuable when in advance you already have the priorities for restoring a particular set of projects, applications, websites. Because you don't need to figure out on the fly, okay, what are you going to deal with first? But instead you already know, okay, these few dozen websites here, we need to tackle those first. Those absolutely need to be online, and then we can deal with the rest. So this applies if you're running some kind of platform or software as a service. If you already know your most important customers in advance and what you should restore first, you can really focus your efforts there instead of having to deal with hundreds or thousands of things that you need to restore and you might not even know where to start. Our infrastructure as code setup also greatly helped us, but as I already mentioned before, there were also still some things that we could improve with it. One thing that was particularly important was that we were able to disable specific automations while we were recovering resources. So this helped us because we could avoid that the operator that is always running and reconciling the resources would kind of accidentally interfere with what we were doing and maybe undo some of the things that we put in place already. And finally, never underestimate small changes. You saw the change that it was just adding one line, deploying to staging, deploying to production, okay, we can do it. It doesn't change much, we know exactly what this is going to do, and maybe not as much care was given to this deployment as when we do larger deployments, like changing out entire components. But that's still, it had a really large impact. We would also like to thank everyone who was involved in resolving, managing, communicating about this outage. And with that, I'll open up the floors to any questions. Would like to thank you for your attention. And I would also like to mention that just last weekend, we actually opened a big new facility that is housing a museum, exhibitions, and science shows at CERN. So if you're ever in the area of Geneva, or you want a reason to visit, come by and have a look at our new Science Gateway. Like I said, it was opened just last weekend and it's actually so new that I couldn't even find a proper picture of it yet, so that's why there's the blueprint here. Thank you very much.